Trigonometric functions of quadrant angles, that is 0 degree, 90 degree, 180 degree, 270 degree and 360 degree. Let us now find the values of trigonometric functions for quadrant angles. What are quadrant angles? They are 0 degree, 90 degree, 180 degree, 270 degree and 360 degree. In radians, they are 0 radian, pi by 2 radian, pi radian, 3 pi by 2 radian and 2 pi radian. They are called quadrant angles because their terminal sides lie along the axis. Now we need to find the trigonometric function values for these angles. All trigonometric function values. Let's use these new definition of trigonometric functions. They are based on the coordinates of any point taken on their respective terminal sides. First, let's go for 0 degree or 0 radian. So we need to take a point on the terminal side of 0 degree, 0 radian. For 0 radian, initial ray is the positive direction of x-axis and the terminal ray also is the same. It coincides. That is why there is no angle measure, 0 radian. So let us take a point on the terminal side. A point on the positive direction of x-axis will look like a, 0. Now, how far is this point from the origin? A units away. It is a units away. Therefore, direct distance also is a. Here, x coordinate is a, y coordinate is 0, and the direct distance r is a. Use these three in these definitions. So sine 0 will be y coordinate upon r. Y coordinate is 0, r is a. So 0 upon a is 0. Now cos 0. Cos 0 is x upon r. X is a, r is a upon a, that is equal to 1. So cos 0 is 1. Now tan 0, y upon x. Y upon x, y coordinate upon x coordinate. 0 upon a. 0 upon a is 0. Now, the rest of the three trigonometric function values, cot theta, sec theta and cosec theta, are the reciprocals of these three. Hence, we will be able to obtain them using the reciprocal relation. Now, let's go for the angle 90 degree, that is pi by 2 radian. 90 degree or pi by 2 radian has the terminal side here, initial side here and terminal side here. So we need to take a point on the terminal side. Here we go. Yes. Now the point is on the terminal side of 90 degree, pi by 2 radian. Any point on the positive direction of the y-axis will look like 0, a. Having its distance from the origin, a units, the y-coordinate will be the height. So the direct distance is a, which will act as r in these definitions. So sine 90, sine pi by 2 is y upon r, that is a upon a, 1. Cos 90 degree, cos pi by 2 radian is x upon r, 0 upon a. So cos 90 is 0, cos pi by 2 is 0. Now tan 90, tan pi by 2 radian. Tan definition is y by x. Y coordinate upon x coordinate. A upon 0. A upon 0 has 0 in the denominator. Once 0 there in the denominator, that value is undefined, not defined. So tan 90 is not defined, We denote it by the symbol infinity. Again, the other three will be obtained by taking the reciprocals. Now we'll go for the angle 180 degree, that is pi radian. Pi radian in the standard position will be drawn like this. So the terminal side is here. We need to take a point on the terminal side of pi radian. This is 180 degree. Pi radian and a point towards the negative direction of x-axis, it will have the coordinate of the form minus a comma 0. Minus a. But how far is this point from the origin? What is the distance? Distance is always taken positive. So we say the P is at a distance a units from the origin. Not that we do not say minus a unit away. It is a units away from the origin. So R is a, x coordinate is minus a, y coordinate is 0. Use these three in the same definitions to have sin 180 degree, cos 180 degree, etc. Sin 180, y by r, y coordinate upon r, 0 upon a, 0. Cos 180 degree, yeah, cos pi radian is x upon r, minus a upon a. Minus a upon a is minus 1. So cos 180 degree is minus 1. Cos pi radian is minus 1. Now tan 180 degree, tan pi radian, y upon x, 0 upon minus a. 0 upon minus a is 0. And now the other three by taking reciprocals. Now we go for the next angle, 270 degree. 270 degree, yeah, 3 pi by 2 radian. It is drawn taking this as the initial ray, and terminal side will be taken in the anti-clockwise direction till here 270 degrees, yeah, 3 pi by 2 radian. Taking a point on the terminal side 0 comma minus a, because the y coordinate in the negative direction, y axis, on the y axis the y coordinate will be minus a taken, and this point P is a units away from the origin. A is positive. So going by the same three definition, let's have sin 270 degree as minus 1, cos 270 degree 0, tan 270 degree not defined, but look, definition is y upon x. Y is minus a, x is 0. Y is minus a, x is 0. Minus a upon 0 is of course undefined, having 0 in the denominator. But since it is negative, it will be termed as minus infinity. Now, next terminal angle, quadrant angle is 360 degree. As we know, 360 degree, 360 degree has same terminal side as 0 degree. And also, since coterminal angles have same trigonometric function values, these values will be same as that of 0 degree itself. Because 0 degree and 360 degree are coterminal angles having same terminal side. 360 degree and 0 degree are coterminal angles. So they will have same trigonometric values. No need to find them once more. They are the same values. Now, how to remember these values? Let's recollect. 0 degree we already had done in the right triangle system also. Now sin 0 is 0, sin 90 is 1. Sin 0 is 0, sin 90 degree is 1. Now if sin 90 is 1, sin 270 take as minus 1. Sin 270 minus 1. These values are now plotted on these diagrams just to remember. Sin 0, 0, sin 180 also 0. Sin 91, sin 270 is minus 1. These two were already learned when we did the trigonometric ratios in lower classes. So sin 0, 0, its opposite here sin 90, sin pi also 0. Sin 91, sin 270 minus 1. Similarly, cos 0, 1, cos pi, cos 180 minus 1. Cos 90, 0, cos 270, 0. 0, 0, 1 minus 1. Tan 0, 0, tan 90, infinity. 0, 0, infinity minus infinity. These are all values picked up from the table itself. These calculated values, just to remember, you may keep this diagrammatic representation.